Good evening, and thank you for joining us on this rainy evening. I'm so happy to see all of you tonight. My name is Liz Chang, and I am the board president for the New England chapter of JDRF. My type 1 connection is my son John, who is about to turn 12 and was diagnosed with type 1 right before his 7th birthday. I'm happy to say that John is doing well, but my family's involvement with JDRF really was a godsend for us at a time when we really were struggling to try to find a source of hope. And our first involvement really with the organization came at a research briefing just like this one. So I really appreciate everyone being here. I'd like to thank the students from Bentley University who are helping JDRF record this event through photos and videos so we can hopefully post it and use these materials beyond this evening for those who weren't able to attend. I'd like to now introduce our keynote speaker, Andrew Rakeman. Dr. Rakeman is the Assistant Vice President for Research at JDRF, where he oversees all of the research programs to prevent and cure type 1. This includes beta cell regeneration, immunotherapies, and the prevention portfolios. He is responsible for the development and execution of strategies to advance the pipeline of academic and industry grants and partnerships, driving therapies to restore immune regulation and beta cell function for people with T1D. Dr. Rakeman joined JDRF in 2007 and brings his biological and immunological knowledge and drug discovery training to JDRF's mission, for which we are very grateful. Dr. Rakeman holds an undergraduate degree in biology from Boston University and a doctorate from Weill Cornell Medical College. His graduate training was conducted in the laboratory of Dr. Catherine Anderson at Sloan Kettering, studying the genetic and cellular regeneration of axis formation and patterning in animal models. Don't know what that means, but hopefully you can clarify. Thank you for joining us this evening.
Thanks, Liz. So I guess it's a choice for everyone. Do you want to talk about diabetes or do you want to talk about early embryo development and axis pattern? I guess it's diabetes. So I'm really excited to be here. Thanks for having me. As Liz said, I'm a Boston connection. I came up here for college at the EU, and I worked for a couple of years at Harvard Medical School with Angela Rousland, who's a really world-class immunologist at the time. So it's great to be back in Boston. I come up here relatively frequently for work, to visit in Boston. It's the first time I've visited the chapter, so really excited to be here. I have to, this is sort of like public speaking 101, what you shouldn't do. I'm going to make a confession to start that. I'm a little bit nervous with this one. One, because, you know, when I got asked to come down there and ask, well, who's giving research briefings, you know, in the past, who's here recently? And I hear the list of Dr. Lewis, Dr. King, and all these world-famous leaders in diabetes. You don't have research briefings. You're one of the master's class in type 1 diabetes down there. What am I going to bring to the table? I said, okay, no, just talk about some things that are new coming out of JDRF and talk about JDRF's role and do it in half an hour. I said, well, now I'm going to go on and on forever and I'm going to get me started and I'm going to stop. So the optimist in me is hoping that somewhere in the middle of not having anything to add between everyone else's talk before and blathering on and on about how terrific JDRF is, we'll somehow meet in the middle, it'll be half an hour, it'll be perfect, and you guys can all tell me at the end how great the job is. But so I'll start off, you know, so I'm going to tell a few stories about things that are coming out from JDRF, things that I'm really excited about, things that I think are really pushing the envelope of these stories. I'm going to try to tell them from the perspective of why did they happen in particular because of JDRF? What is it that's different about JDRF that helps to drive research forward in this way? And you'll hear some themes about JDRF as a leader in the field, JDRF as a convener who brings different groups of different kinds of expertise together, JDRF as a risk taker and a gap filler and stepping into areas where other people aren't, other organizations aren't working. And hopefully everyone can leave here with a real sense of pride that we're all part of something that's really special, that nobody else is doing, and stuff that won't happen unless everybody else in this room and all of our friends and everyone is getting together to support this mission. So I hope everyone here leaves incredibly energized about what's happening. I know I'm really energized, and these kinds of events are some of the most motivating things that I do. So start with a few facts and figures. It's probably stuff that everyone in here knows. JDRF does a lot, right? So we funded a lot of research. We've given a lot of grants, but a few numbers on here that I think are important. One is the 70 plus active clinical trials, either directly funded or supported by JDRF. That to me shows that research really is moving forward. We don't get to new therapies, we don't get to anything moving forward into the clinic, making a difference in people's lives, unless we get into clinical trials, unless we bring things to that level. So as that number is growing and moving forward, it's really a sign that, yes, the research is moving forward. Not everything is at the point yet where it's making a difference in everyone else's lives, but it's moving towards that goal. The other two numbers at the bottom, one is we go all over the world. JDRF goes where the research that's happening is the best. JDRF goes where it's going to be fastest to drive to the clinic. Yes, there's lots of fantastic things happening in Boston. There's tons of really smart scientists in Boston that can get stuff done. When Boston's not the best place, guess what? We're going to fund elsewhere. We'll fund in Sioux Falls, South Dakota. We'll fund in France. We'll fund in Australia. We'll go into Canada. We can get great support there. Because we want to be where the work that's happening is the best that's going to drive us all towards our goal. And the other thing about the team in New York and my colleagues, that there's 20 Ph.D. level scientists working in New York. And that's a pretty high number for a disease foundation like JDRF. And that's a real conscious decision that JDRF made. We're going to be an organization that's out there and knows more about type 1 diabetes in the landscape and knows how to put the work that we're doing to the best use possible. So I work with a fantastic team in New York, probably some of the best who know more about type 1 diabetes than anyone else in the world who can put us together. And really the ones who are making the decisions about what's best, what's the real next step, how do we move things forward as quickly as possible with the available funds. So research isn't all that JDRF does. I'm going to focus a lot on the research progress here, but just to give a reminder that we're not getting anywhere unless we're making therapies available to people and we're driving them forward. And that's more than just making scientific discoveries. That's bringing in additional players and additional funders and getting everyone else excited about what's going on. That's making efforts with advocacy to make sure that therapies that are out there and approved are available and being covered by health insurance policies. That's also doing research. That's also doing kinds of research that we hope will spill out into government-sponsored programs and things that will move beyond JDRF support. And I'll give some examples of all this. But again, just keep in mind that it's not just research that's important to move forward. And that's sort of summarized here in this part of the graphic. We're often, when we talk about progress along research, we talk about moving along a pipeline of discoveries that starts from the basic science all the way on the left and moving into better outcomes for people on the right. And you can see here this is broken down into a number of stages here. There's 5 stages that go along the pathway. There's other models that could break that into more or less steps. But the point here is that each of those are critical to delivering better outcomes. If we make fantastic discoveries and we can't move them into a company that's going to turn that into a therapy, we fail. If we've developed a therapy and we can't get it through the FDA, we fail. If we get it through the FDA and we can't get health insurance companies to cover it and to get it paid for and get doctors to prescribe it, we fail, and we have to move that into better outcomes. So JDRF really needs to work across this entire continuum. JDRF is really probably the only organization out there focused on type 1 diabetes that is working end-to-end, soup to nuts, against all of these different areas. So I'm going to really focus on what's happening more towards the left of this on research, but know that every time we see different gaps that are impeding our progress, JDRF is looking at new models to bring things and accelerate that. The type 1 diabetes fund is something that Sean and folks here are very familiar with. And that was a recognition that the business models and the investment models that existed made it a tough environment to start new companies focused on type 1 diabetes. And could JDRF fill a gap there that says, let's lower the barrier there, let's make it easier for investors and companies to start and get involved here. Back in the early days of the artificial pancreas program, we recognized that there was going to be a huge regulatory hurdle on it. So we built up a team in DC with regulatory expertise that works closely with the FDA, not just on artificial pancreas, but against all of our objectives, to make sure that they're educated about what's coming down the line. And that's taken, years off of the time of bringing new therapies forward. We also have a team in DC that works with payers that helps to make sure that these therapies, once they're available, are going to be reimbursed and accessible by the folks that need them most. So So we really try to work across this whole spectrum. And the reason why JDRF is able to do that is we have all the different pieces in place, and really in particular because it's an organization that's driven first and foremost by the voice of the patients and the families that are impacted by type 1 diabetes. Really the way to be able to have credibility with all of these different audiences and be able to talk about the needs across this entire spectrum is when you speak with the voice of the folks that are impacted by type 1. So again, something really critical about the role of JDRF. We work across the entire spectrum. But that said, we don't work there alone. There's lots of other fantastic organizations that are in the cause with us, the Homes and Charitable Trust, the Type 1 Diabetes Exchange, the people at NIH, and other government funders. And it's something, I saw this graphic actually as I was walking in here, where JDRF, through our leadership role there, is really able to bring in additional resources to bear on our cause and really be taken as the leader in terms of bringing the money in there. So the estimate comes out as for every dollar that JDRF is able to put out into type 1 diabetes research, another $2.50 comes in from other sources, whether it be through the NIH and the Special Diabetes Program, through government-funded programs, through Canada and Australia that bring money in, through co-funding with our industry partners, and working with other charitable funders and NGOs to drive things forward. So we're not doing this alone, but JDRF really is that only organization that can see the entire spectrum across that. When the governments come in and fund, they can't have those kinds of interactions and discussions with the regulators that JDRF can. When private foundations come in and fund, they can speak with the voice of sometimes a single patient or family. They can't speak with the voice of everybody in this room and all the domains across the country that understand the impact of type 1 diabetes. So JDRF really is unique in this role here. It really puts us at that corner, at the leading edge of this pyramid. So with that, I'll switch in to talk a little bit more about what most people want to hear about is what's new, what's happening, what's going on in the research program. So I know there's a lot that JDRF does. We have a lot of different research priorities, a lot of different ways that we talk about what we're doing, restoration and insulin replacement, prevention, et cetera, et cetera. But really, if you boil it down, is JDRF first and foremost is driving towards a cure for type 1 diabetes. That's the real. We know as we're driving towards a cure, we can make people's lives better, we can make diabetes easier to manage, and we want to be able to make sure that everybody who's living with type 1 diabetes now lives a long and healthy life and is able to benefit from a cure when that does come. So we can think about overall what we're doing is to cure, treat, and prevent type 1 diabetes. I'm pretty simplistic about these things. I think a cure is taking people to take insulin now, and they don't need to take insulin anymore. That to me is sort of a cure. Prevention is somebody who's at risk to having to need insulin in the future. We're going to remove that risk. They won't need to go on to insulin therapy down the road. And better treatments is making the use of insulin and management of diabetes easier, making insulin better, work better, easier to use down the road. That's sort of my very simplistic look. So driving towards a cure really is the main goal for JDRF. So why are we looking at some of these things earlier on around better treatments, for example? Well, we know everybody in this room here knows type 1 diabetes is not an easy disease to deal with, not an easy disease to manage. And here's some more data that really brings that point home. So this is data from the Type 1 Diabetes Exchange, where they went to some of the top diabetes clinics around the country, surveyed the patients there and said, well, what's your HbA1c? How close are folks with the best care available in the US and the top diabetes clinics? How close are people getting to what we're saying is the targets? HbA1c of less than 7.5 for kids and less than 7 for adults. And shown here is the percentage of folks in the tall blue bars who are not making it there. So it's 75, sometimes more percent of the folks are not hitting their targets. And this is not because people don't have access to the best tools and technologies. It's not because people don't have access to the top doctors in care, because these are from the top clinics around the country. This is because type 1 diabetes is a tough disease to manage. And quite frankly, the tools that are out there now are not adequate to drive towards really idealized control. I'm just going here, the big blue bars are HbA1, folks meeting their HbA1c targets or not meeting their HbA1c targets. The yellow and the green lines in the bottom are percentage of folks who experience a severe hypovolemic or DKA event in the past 3 months. So that also are numbers that are unacceptable, that they're higher than they should be. So we do need better treatments. because we do need to keep people healthier in the meantime. So a lot of the effort that JDRF has been driving along this goal has been around, well, we have insulin available today. We have good devices to deliver insulin, we have good devices to measure blood sugar. Can we improve on those and make them even better and really drive towards a fully closed loop system ideally that will deliver insulin automatically, not require a lot of insulin, but of course managing it. As everyone knows, recently the first hybrid closed loop system, or the first step towards a real artificial pancreas system, the Medtronic 670G was approved a little while ago, and that's out there and people are benefiting from that. We hear from our friends at Medtronic that they think that all of the work that I talked about that JDRF did in terms of laying the groundwork with the FDA and the regulators and setting this landscape took probably between 5 and 10 years off of that timeline to getting a device like that approved in the hands of people. Right? So when we talk about that end-to-end view, it's not just academic. It's not just saying, oh yeah, it's going to be everywhere. We make real differences at each of those stages. Now, delivering a therapy like this required some new technology development around new algorithms and new pumps and new sensors to make it possible. But it was also very important it took an understanding of the regulators that these is a different type of way of thinking about managing type 1 diabetes and getting them accustomed to it and laying the groundwork for how something like that's going to be approved. As many of you have seen from coverage to control campaigns and things like that, it's also really important to make sure that the payers are on top of these are technologies that give benefit that people want, that need to be covered and paid for. So really driving towards that. So the Medtronic system is out there. We know that there's other folks coming along with newer systems, with other types of systems. I expect we'll see continuous improvement in terms of better pumps, better sensors, smaller pumps, better insulins, things like that will continue to get better and better. But if I think what's going to be really the next scene change in this kind of field that will really blow things open and have us think about it in a different way, it's less about the technology and changes in technology and more about how that's delivered and how we interact with it here. So I'm sure everybody in this room who went around and said, what's your favorite pump, what's your favorite sensor? There'd be different answers from everyone because people have different priorities. And we want to make sure that folks have that kind of choice out there in terms of what they're achieving. So there's been groups out that have looked at, well, do we need a Medtronic out there that has its own sensor, its own pump, and its own algorithm, and wait for them to put it all together in a package? Or can we build our own package? And there's been folks who have been hacking into or opening up old pumps and old sensors and getting them to talk to each other and sort of building their own hybrid closed loops. Right? It's something that's been happening sort of under the table and sort of the back alleys and stuff of diabetes technology. And we looked at this and said, hey, this is going on. People are benefiting from this. This isn't going to stop. How do we make sure that this is going to happen in a way that's going to be safe for everyone? It's going to be regulated in an efficient way. And it'll be available to more and more people, not just the folks that happen to have old pumps in their drawer or have the wherewithal to just go and build their own system or do it through their own coding. So JDRF has really looked at what we call open protocol systems. Can you open up the protocol so that any pump and any sensor can talk to each other and move along with each other? You can add in your own algorithm and talk about that. So you can really design a system that works best for you. We know that there's going to be some challenges on this. There's regulatory challenges. This isn't something that the FDA is normally used to looking at. There's liability challenges. Who's going to be the one who's accountable if something goes wrong in a mixed system like this? And there's also some research challenges. New technology that needs to be developed in terms of developing open algorithms, developing open pumps and sensors. So JDRF is really taking this head on. We had a meeting with the FDA, a workshop at the FDA that talked about this, and much to our surprise and a lot of things, the FDA has actually taken a leadership role in this, and the Dexcom G6 was actually approved by the FDA as what they call an iCGM, an integrated CGM, that's able to talk with other devices. So far there's no other device that it's approved to talk with, but it's a step in the right direction. We know that some of the pump companies are submitting new pumps for approval, or submitting them as iPumps or integrated pumps. We'll be supporting some other pump companies to open up their systems to do the sort of technology development. And really looking at, well, what does that liability structure look like? We're talking with some lawyers to see how do we make sure that this is going to happen in a predictive way. So this is something, it's still in early days, things are still moving forward, but something, if you think about it, I think would really change the landscape of diabetes devices. And now you didn't need to be the Medtronic who owns it all, and put it all together on. So the smaller companies can come in and innovate and bring in years of integrated products. Patients have a choice of what they want to use when they bring it together. So this is something that I think is coming, it's going to happen. JDRF is really trying to make sure that it happens in an efficient, safe, and timely way. And I think it's really going to change the landscape of diabetes devices. The other thing I think really is a sea change in the way we think about treating type 1 diabetes and controlling blood sugar in type 1 diabetes is thinking not just about insulin. So since almost 100 years ago when insulin was discovered and started to be used as a therapy, all of type 1 diabetes treatment is focused on how do you manage insulin, how do you use insulin to manage blood sugar. It's very different from how type 2 diabetes is managed, where people really look at, well, what are, not just insulin and the pancreas, but what are all the other organ systems and physiologic systems that impact blood sugar and glucose control? So that includes the kidneys, the liver, the muscle, the fat, the brain, the central nervous system, are all part of the systems that control what happens with blood sugar. But those are not really factored into how we think about treating and how we treat type 1 diabetes. But it's something that's going to be changing soon. So there's a new class of drugs that's been approved for type 2 diabetes for a little while, SGLT inhibitors. So long story short, they work in the kidneys by interfering with the mechanism that takes sugar out of the urine and puts it back in the blood. So when you inhibit these, it lets you pee out sugar. It lets it stay in the urine. And they've had tremendous success in type 2 diabetes, including blood sugar control, actually reducing cardiovascular complications and reducing kidney complications. There's a company that JDRF was aware of, Lexicon, that is developing one of these. And like JDRF got involved with them early on and said, hey, why don't you try these in type 1 diabetes? And supported them to run some clinical studies in type 1 diabetes, which looked good. They moved on and ran their phase 3 studies, and are now going to the FDA asking for approval for their drug, with their first indication being type 1 diabetes. So it's out there now, the FDA is taking a look, we don't know what's going to happen. We expect early next year they should have their decision. But if this does get approved, this one will be the first one that goes for type 1 diabetes first, and it will be the first drug approved for type 1 diabetes if it is approved. That does something other than replaces the hormone that's missing in type 1 diabetes. So, I don't want to necessarily oversell the benefits of SGLT inhibitors, but this is a real sea change in terms of how we're thinking about treating type 1 diabetes and thinking beyond just insulin, beyond the pancreas, and looking at all of these other organ systems that play a role here, and thinking about it in a much broader sense. And again, JDRF out there driving and taking a leadership role and convincing these companies to think about not just type 1 diabetes as an afterthought, not just type 1 diabetes as a get used on the side, but leading with type 1 diabetes and a real major change. So with that, I'm going to shift gears a little bit and talk more about the work that I'm more directly involved with and that my team is running around cure and prevention of type 1 diabetes. So a conversation we were having just before, and I apologize for this slide, is kind of dull and kind of busy. But if you think about basically any other autoimmune disease compared to type 1 diabetes, is people are aware of other autoimmune diseases as they're happening. So if you have autoimmune alopecia, you see your hair fall down. If you have vitiligo, you see changes in your skin in those early stages. You have RA, you feel joint pain. If you have MS, you feel some loss of mobility at early stages. In type 1 diabetes, nobody goes, oh man, my pancreas has really been bothering me. I think I'm coming down with something, right? It's not until estimates somewhere between 80 and 90% of the beta cells are gone that people start to require insulin from outside. So most of what's happening in type 1 diabetes, we're unaware of. All of that early stage of development, we're unaware of. So there's been a number of studies going on for decades, supported by the NIH, supported by JDRF, supported by others, that are looking at, well, what are those early life events? And all that data started to come together, really pointed out some very predictable stages that type 1 diabetes proceeds through. And JDRF led an effort that involved all the other big diabetes organizations to say, well, let's put some definition around what are those early stages of type 1 diabetes. So it's not just you're off insulin and you're healthy and you're on insulin and you have type 1. Well, there's things that are happening. So we have these now called stage 1, stage 2, stage 3. So stage 1 means you have 2 or more autoantibodies. I'm sure a lot of people in here are familiar with TrialNet and these screening programs that look for autoantibodies. These are the first indication that the immune system is starting to recognize itself. It's starting to recognize the beta cell. And we know that folks who have 2 or more autoantibodies, their risk of developing type 1 diabetes in the short term is pretty high, about 50%. For the next 5 years, 75% for 10 years, and the lifetime risk of developing type 1 diabetes is essentially 100%. Okay. So now we can say that that's stage 1 type 1 diabetes. That's not, you might get type 1, that's not, the sibling of type 1 and you're at higher risk. That's the beginning of type 1 diabetes. We know that after that, you go through a stage where you start to lose some control of blood sugar, probably some beta cell loss, but it's not enough to be insulin yet. So we call that stage 2, where there's multiple autoantibodies and dysglycemia. So that you feel like blood sugar will get higher than it should, but you don't need therapy for that. And then stage 3 is requiring hormones. So now this sort of agreement of everyone that this is the stages that define type 1 diabetes is a huge change in terms of how we think about it, when we can get involved in treating, and how we get involved in treating. JDRF is now working with a group called CPATH to work with the FDA to do what we call qualify islet autoantibodies as a biomarker for type 1. That would mean that the FDA puts their stamp of approval that yes, this is a valid biomarker for this process, and really try to bring this into practice. And what this kind of staging enables is, well, then we can screen for folks who are at risk, identify folks, and hopefully be able to intervene in the meantime. So, a lot of questions that come up, and I know I've had a lot of these questions, discussions with people talking about TrialNet and some of these other screening programs as well. Why would I get screened if there's nothing that we can do to stop it? Why would I want to know? It's just and so JDRF has been supporting some of these screening programs. You see a number of them up here on the slides. ASK is in Denver, they screen for type 1 diabetes and celiac. DIP is in Finland, and DIF is in Australia. They screen during pregnancy, actually, look at moms with type 1 and look at the babies. FREED is a big program we're running in Germany. And one of the things we've learned from all these programs is the kids that get screened early on, that they identify as in this early stages, stage 1 and stage 2, and they follow up for a long time, their risk of diabetic ketoacidosis or DKA at diagnosis goes down to almost 0. So in the general population, most people who are diagnosed with type 1 diabetes that show up in the doctor's office or in the emergency room feeling very sick, the rates of DKA are somewhere between 30 and 40%. They go down to 5% or less in the screening studies. So while it's true that we may not be able to do anything right now to really slow down or prevent type 1 diabetes from developing, we know that there's a huge benefit from knowing people's risk early on in terms of avoiding DKA, which can be fatal, which causes a huge amount of stress on the family at the time, can require intensive care stays, and has long-term effects in terms of long-term glucose control and outcomes in folks that experience DKA. So we know that there's going to be a benefit there. So what we're now doing is working with these different screening programs, working with government agencies to see, is this something that it makes sense, that it's cost-effective, that there's benefit from having done in a local way? This is something that every kid should be screened at certain stages during their child visit. So that's where these studies are really geared towards. Can we truly prevent DKA and identify everybody who's at very high risk of developing type 1 through sort of broad-based general population screening? Now that's avoiding DKA is fantastic, and I hope that we can get that down to 0, as close to 0 as we can. But ultimately, what we want to be able to do is intervene in these kids and these folks and really arrest or slow down dramatically the progression of type 1 diabetes. And that then really brings us to, well, what are we doing to cure type 1? So like I said, we're saying stage 1 really is the beginning of type 1. What we want to do to prevent is really the same thing that we want to do to cure. So this is my to-do list. There's 2 things we need to do. It's really easy. We need to stop the destruction of the beta cells, we need to stop autoimmunity, and we need to replace or restore the beta cells that are already working. Okay? It's an easy task, right? For 11 years, it hasn't been done. Right? So these are, I'm being a little bit flip about it, but It's very different in terms of thinking about it. I know that these are tall orders, and it's a lot to want to be able to change the course of a disease like type 1. But knowing what we're up against really changes the discussion that we have. If we look at these individually, there are steps that we can take along that direction. And what I'll share with you is a couple of things that I think we're really driving towards getting to a point where we can stop or slow down the destruction of beta cells. I'll show you an example of a couple of things that we know that have that kind of impact. But then how do we get them into the hands of patients, and how do we start to build on initial small successes to add up into something that's going to be really big and impactful in the long term? So we've known for a long time that type 1 diabetes is an autoimmune disease. We know that from studying about the pathology of type 1. We know that from clinical studies that we've run using agents that disrupt the immune process that can slow down progression of type 1 diabetes. But we also know that there is still no approved therapy for type 1 that targets the immune system and slows down type 1 diabetes. And this is in contrast to other autoimmune diseases like RA, like MS, where even if you watch TV for any amount of time, you'll see commercials for these drugs that are out there for these diseases that really change the course of them by interfering with the autoimmune process. A number of these therapies that we tried in type 1 diabetes, they do have effect, but not enough of an effect that anybody's been able to get one approved yet for type 1 diabetes. So among all the things that we're doing in the immune program, we're looking at new targets, we're looking at new ways to we're looking at new ways to understand type 1 diabetes in itself. But we're also looking to our friends and our colleagues from other autoimmune diseases to say, hey, what is it that you guys did that helped you to be successful? What is it that's similar between MS and diabetes that we can learn from? Or similar between vitiligo and diabetes that we can learn from to build on those successes? There's also been a real exciting shift in the way we think about treating cancer and the development of these cancer immunotherapies, of turning on the immune system, ramping up the immune system to get it to destroy the tumor. And we've seen cancers that were previously fatal 100% of the time now really being cured in some individuals through these cancer immunotherapies. One of the side effects, common side effects of these therapies is that people develop autoimmunity after being treated. So the cancer gets cured and then they'll develop type 1 diabetes or other diseases following. So there's also a huge opportunity there. So my colleague, Cindy Ahmed, who runs the immune program, she had a big workshop last June where she brought together leaders from all these different autoimmune diseases, leaders from cancer autoimmunity, to have this conversation about how do we all learn from each other and how do we move forward. And that's going to be a really forward-looking area for JDRF in terms of looking across all of autoimmunity and how do we bring success in the whole field together and continue to move forward. All along the line, again, we're having those discussions with the regulators, we're having the discussions with the payers, what's enough of an effect to see, to want to be able to pay for something like this, to really set the stage for when we have that success to bring it forward. So really exciting stuff on the immune side, both in the world in general as well as in type 1 diabetes. Also on the beta cell side, when I first started at JDRF, I started as a scientist within the newly minted beta cell regeneration program. And at the time, JDRF was starting this program. We had a lot of pushback, to put it nicely, from some of the leaders in the field out there. Said the beta cells are a waste of time in type 1 diabetes. By the time anybody is diagnosed, all the beta cells are gone. Even if you could do anything about it, the beta cells are kind of lost cause and not really driving the disease. JDRF took the risk, put together the regeneration program, studied the role of the beta cell in type 1 diabetes, and we learned a huge amount. We learned that a lot of people who are diagnosed with type 1 have beta cells remaining even for years, for decades after their diagnosis. And many people who have had diabetes for a long time still have active beta cells that are still making insulin. And guess what? The people who have even a few beta cells, they tend to do better than the people who have none. Everybody still needs insulin, everybody still needs to manage their sugar, but fewer complications, short and long-term complications in the folks that have even a small amount of remaining beta cell function. We also know that the beta cells and beta cell stress is one of the things that's driving the progression of type 1 diabetes. So as beta cells get sick and they get worked up and stressed out, and this is something I'm sure Dr. Hood Missergill talked about when he was here, that can make them more attractive to the immune system. That can lead them to die faster and fall off faster. So one of the projects we were involved with was a researcher in Alabama called Matt Shella, and she was studying beta cell stress. And through her studies, happened to stumble upon the fact that an old blood pressure medication called Rakeman could reduce stress in beta cells, and if you treated diabetic animals with it, you can stop and reverse their diabetes. So we supported her to do a small, very small study in adults who had been recently diagnosed with type 1 to see if you gave them this old, cheap, safe blood pressure medication, does that impact the progression of their type 1 diabetes? And she found, and this was published earlier this summer, that you actually saw a slowing down of the progression of type 1 diabetes in the folks who got Rakeman compared to those who didn't. Small study, it was about 25 patients altogether, some with placebo, some with the drug. These were all just adults. But that first indication that, hey, the beta cell isn't just an innocent bystander, it's something that's participating. And if we can intervene not just to slow down the immune attack, but to make the beta cells healthier and happier, we can have an impact in terms of prevention of type 1 diabetes. So we're now working with Matt and others to see how do we take this to the next level, how do we replicate that study, extend it to broader patient groups, and move it on into something that's going to be impact. One other way we know that can help that can be effective to bring back beta cells in people with type 1 diabetes is to simply transplant the back end. So people with type 1 diabetes who get a transplant of the pancreas, or who get transplants of just the islets that contain the beta cells, can live for many years, sometimes up to 10 years, without the need for insulin. So sounds fantastic, right? The downside is, in order to get a transplant like that, you need to go on a lifelong immune suppression. And for most folks with type 1 diabetes, diabetes is a lot easier to manage than immune suppression and a transplant. So for most folks, it's not a viable alternative. But for those who have really tough time managing with type 1, have severe hypoawareness or chronic short-term complications, this can be a viable alternative. So you need, in order to do a transplant, you need an organ donation from somebody who passes away, and you need immune suppression. Two things that we can work to try to overcome. So JDRF has put together what we call a beta cell replacement program, and under that, the encapsulation consortium to say, hey, let's try to figure out how do we get around those two big challenges. And not dissimilar to the early days of the artificial pancreas program, where we know we needed folks that could write the algorithms, and we needed folks that could develop new pumps, and we needed folks that could develop new sensors. If we're looking at replacement of beta cells in an encapsulated product, we know we need cell biologists, we need immunologists, we need materials experts that are coming together and have them all work together. So that's why we took a consortium approach here. And JDRF is really as the convener of this disparate group of experts and scientific leaders to say, hey, can we address the big challenges out there? We've seen tremendous progress in this area. There's a company, Biosite, who's in clinical studies with their encapsulated stem cell product. They're the leaders in the field. They're probably the only company right now. So the Medtronic that has all the pieces together. But there's lots of other companies that are looking at bringing in each different aspects. One of the big success stories that we had recently came out up here from Boston at the Bob Langer's lab, where he had been working on finding new materials that the immune system wouldn't recognize that you could use to coat, encapsulate, and cloak these transplanted beta cells. And had some great discoveries, formed a small company called Sigalon, and that was recently purchased by Lilly. Right? So we know now that these big companies are starting to really look at this and get engaged here. And not only is it really making a big play here, but we know that all the big insulin manufacturers, so we're starting to look really hard in this area, driven by the very strong proof of concept that we know that the beta cells back works. And knowing that, yes, there's some big challenges in there in terms of overcoming the need for immune suppression, in terms of having a really robust source of beta cells, but that's all moving forward. Another company that's driving towards this is Senate, which is formed by the Third Mountains Lab here in Boston that had some real carrying on with some real big breakthroughs that he had in terms of driving towards forming new beta cells from stem cells. So lots of progress in this area. I think this is something that's going to move forward. pretty quickly and start, or we're going to move forward and have a big impact as we address some of these challenges that we're having. So, I tried to talk about, what are all the different things that are exciting. I know that talking at these events, I love coming to these things, it's very energizing. It's also a little bit sometimes like preaching to the choir, right? I know everybody in this room is already engaged, everybody in this room is hopefully already an advocate and out there helping to be pushes. But I hope everyone here is also going to leave with, maybe one or two tidbits that you didn't know before that you can go out and share with your neighbors, with your coworkers, with folks around you to say, hey, come on, let's get going, let's be part of this. It's always easy to convince somebody to be part of a winning team. And I can see the strides that JDRF has made. Hopefully everybody's with that. So here's some ways I'm sure everybody in this room here is engaged and continue to be engaged. I also do want to point out probably the most, not probably, definitely the most personal way anybody can participate is to participate in clinical research as a research volunteer themselves, participating in clinical trials. I've talked about trial med a couple of times. It's a way for not just people with type 1, but their family members to get involved in understanding about type 1 diabetes. There's lots of other different trials out there available. JDRF has developed a tool called Clinical Trials Connection, which if you go and search for it, you can find where you can put in your information and see if there are clinical trials nearby you that you would be a match for to participate in. But again, any of the progress that's out there now, whether it's new insulins being approved, new devices being approved, new classes of therapies like SGLT2, all of these go through a similar bottleneck of they need to be tested in volunteers who take that risk and are ready to participate and give up themselves to keep them moving forward. So we put that out there, I'd love for this to be engaged and involved. This is a slide I put in really for me. It's a reminder to me on what a fantastic community JDRF is, and look at all these different people participating in different ways, whether it's through fun events, through lobbying events, through sharing their stories and being out there. I didn't talk about myself as much at the beginning. I don't have a family connection to type 1 diabetes, but after 11 years of coming around and visiting different chapters around the country and talking with people, hearing lots of different stories, I feel as if I have a very deep personal connection. And I just wanted to thank all of you for being part of that. For me, energizing me in terms of work. So with that, I'll say thank you, and I'll be more than willing to take questions. That's always the best part of it. Questions? I think there's microphones.
For individuals that are identified in the stage 1 process, what do you do to bring their risk down to 5%? Is it diet, or is it use of the blood pressure medicine, or what types of things may continue to help?
Yeah, it's a great question. It's a fantastic question. So it's about, I said you can get TKA rates at diagnosis from 30 or 40% down to less than 5%. What's the secret sauce? What's the magic that makes it happen? Is it a new drug? Is it a diet change? The answer is much simpler than that. It's just monitoring and following up on people. And making sure that people are aware of what are the signs and symptoms of type 1. What does it mean when you start to progress to that next stage? And having people be aware and getting into the doctors earlier and getting treated earlier. So often we talk about that and people say, well, I have one kid with type 1, if another one starts down like that, I'll know it right away. Right? But the reality is even for that second kid, the rates of TKA diagnosis are still somewhere, they're a little bit better than 30 or 40, but they're more 20, 25%. So even the parents that are really tuned in, we're still not as good as glucose monitors. We're still not as good as regular checkups to really see the symptoms. If you think about the symptoms that you do notice, if it's fatigue or thirst or frequent urination, those aren't things that happen at 150, 200. Those are things that happen when you get pretty high and get into as well. So the short answer is it's really simple. It's just close monitoring and visits with the physician. It doesn't take much more.
Just a quick question, 2 quick questions. Quick questions, if you don't mind. TV shots. I see that it appears that they are also helping with type 1 diabetes. You want to add anything to comment on that? Are you aware of that?
Yeah, more of that. So this is work that a researcher here in Boston, Denise Faustman, has been talking about for a long time, that immunization with a vaccine called BCG, which is used for TB, can have benefit in type 1 diabetes. Some people believe it can have benefit in other types of regulation. It's an area we've definitely been following quite closely. Actually, I was speaking with Dr. Faustman recently at the Immunology Diabetes Society meeting. So far, the number of patients that have been studied with type 1 that have been treated with these kind of vaccines are pretty small. So she published recently around a small number of patients that have been followed for a long-term period of time, and could show in that small number looked to be a benefit in terms of glucose control, although it didn't seem to be driven by a direct impact on the immune system of the beta cells that operate a different type of. So it's something that we've been watching and looking at. Haven't seen yet the kind of data on a very large number of patients that would really suggest that this is a technical solution.
One more quick question. I don't know if there's any studies that have been done. I have 2 grandchildren that have type 1. And my granddaughter was discovered she had to stay in the hospital for 2 or 3 days, so they got her blood sugar regulated and stuff. And my daughter put her and her brother, who was type 1, on an extremely low carb diet. And she basically 2 years now has not taken any insulin. If she wants to take a donut or something rare, very rare cases, she will take a shot. And the same with my grandson. Their blood sugar actually, hers is down around 50 at night. That's healthy for her because there's no problems. But she did have to get some steroids a month or 2 ago. That's really thrown her off. But my question is, has there been any studies with children who are put on very, very low carb diets as far as progressing through life, as far as being healthy and normal?
Yeah, so the question on low carb diet and type 1, and I think it's fantastic to hear that your grandchildren are doing very well with it. I think it's not a surprise that if you can avoid carbs and you can avoid sugar, it's easier to control your glucose. Now, in terms of what I think that you're suggesting here, of whether or not low carb diet from very early on would be something that preserves beta cells or arrests progression of diabetes from higher, that's something that we don't know if that's really the case. And I think, as you point out, the risk of very low carb diets can be driving towards low blood sugar and not having that balance of being able to bring blood sugars up and down by balancing carbs versus insulin.
Just to follow up, has there been any studies with people who have put their children on very low carb diets as far as them staying healthy and developing properly with no problems?
So that I'm not aware of. I'm not aware of any studies that look at long-term impact, positive or negative, of being on very low carb diet on a very young age. I don't think has been studied exhaustively.
Thank you very much.
Say this group can't be that quick. I mean, this has got to be the best educated chapter out there.
How close is a fully closed loop system?
That's a good question. So getting towards a fully closed loop system, so how close are we? So I'll take that first from what are the challenges to get to there. So as everyone here knows, so somebody who doesn't have diabetes, if I sit down and I start looking at group, my pancreas starts making insulin, I start secreting insulin, and the insulin my pancreas makes goes directly to the liver and works minutes to seconds, right? the skin, takes half an hour to an hour to start working, and sticks around for much longer than it should. So that really is one of the big bottlenecks in terms of delivering a really fully closed loop, set it and forget it, and replicate the system. Is that you'll never have, or it's very difficult to have under the skin delivered insulin that's going to respond to the meal as quickly as a pancreas. So how do we get there? And there's a couple of paths. One, and ideally we have an insulin that works much faster in the way that insulin out of the pancreas does. So you can do that with having a modified insulin that works much faster and turns off much faster than that sends out big waves extending. You can deliver it to a different place on the skin where it would have those kind of challenges to deliver it into the peritoneum and into the gut or directly into the liver. Have an insulin that works in the liver first, also liver targeted insulin. Or people look at it from, could you have more than one hormone in the system? So have two competing with each other, so it's like we bring up sort of that to be able to work faster together. So none of those approaches are, I think, solved. Probably dual hormone is the closest, but that has some other challenges around developing the deposit, getting the dose right, and understanding what does chronic dosing in terms of long-term side effects. We don't yet have the kinds of insulins that work as quickly as we need, but there's a lot of work going on into that. There's there already are some approved systems that deliver insulin to the report into the peritoneal space that do work best and haven't incorporated into closed loop systems yet, but they also require somewhat invasive surgery and implantation of something. So I know it's kind of coming around directly answering your question. The short answer is that I don't know. I know that there are some challenges out there that need to be sorted before we get there. But the upside of it is those challenges are understood and they're to be built to work with. It's going to take another technological breakthrough, whether it's in insulin delivery, or using another one before we can get to a system like that that's really simple. Yeah,
I have two quick questions. First, in terms of, is there any research on alternative delivery systems? And I kind of asked this from my background because he obviously was like, my kid gets where I instillated my water and just drink it. But I remember reading over the summer there was a Harvard lab that developed some sort of pill that was IV acid in the stomach and be able to deliver the insulin to the spot where it needs to go. Excuse me, I'm blurring out. But I just was wondering if there was research for alternative delivery system.
Yeah, it is. That's a good question. So, and it's somewhat related. So, are there ways to get insulin into the body other than injecting shots? Nobody likes symptoms, right? Even people deal with that for a long time. So there is some. I think the leader out there, there's a product out now called Prezo, which is an inhaled insulin, not approved yet for very young kids. And it's because of the low inhaler, and you can take it off. It works a lot more quickly because it gets into the circulation in a different way. And some people who use it have very positive experiences. It's not very widely used yet. In terms of some of the other challenges, in terms of orally available, like a pill insulin or something that you drink in your water, come in exactly what kinds of challenges that you brought up. It's how do you get it through the digestive system, through the gut, in both a timely way, area we talked about before, even having the skin is pretty slow. And in a way that it's going to survive and have the known potency after being digested. So there's not a lot of work on oral glucose-lowering insulin. There's oral insulin for as an immune tolerizing agent, so basically like a vaccine that will make you tolerant of the beta cells, so that it stop the immune system, but not because of it. So the alternative delivery sites tend to be implanted or delivered through the peritoneal space.
Thank you. you. And just one follow-up. Do you know, this is maybe more for Dexcom, if will be a link between the receiver and the cellular iPhone watch? Again, my 5-year-old has to carry around an iPhone, and it's kind of just cumbersome. You know, his teacher has it, but just a watch would make that system so much better to share with everyone. Are you aware that's being developed?
So very specifically, I don't know how close they are in terms of having the Dexcom share available on the watch.
Thank you.
Can you comment on subcutaneous CGMs, please?
Yeah, so there's implantable CGMs. Yeah, so there's been ever since it is approved now, CGMs that are implantable, they go into the CV with something that's, like a tic tac that goes on there and can measure glucose, and then you have a reader that you put on and can send the glucose values out. From what I know, which is not, admittedly not an expert in this, is that they do seem to work. They're out there approved now. How much people are using them, I think it's pretty new to see whether or not that if it's going to be a real takeover and inhibitor there. It still requires both the implant and something on top that can be a transmitter to be able to read the values out there. But it's new technology, and as I said at the beginning, a lot of this is about preference and works for something in particular, and people having preference for certain sensors, whether it's because it works better with their particular physiology, or it's easier for them to wear, or they react differently to the adhesives. It's all part of it. So it's very welcome to have new types of approaches. But in terms of whether or not it's something that truly differentiates from existing sensors, I haven't seen that.
Just wondering, whatever happened with smart insulin?
Yeah, so that's good. I didn't talk about it more just because there's lots of other things to talk about. So smart insulin or glucose responsive insulin or insulin that will turn on when your blood sugar gets high and turn off when your blood sugar goes back to normal. So it's very nuts for the Boston success story. There was a group at MIT, the JDRF funded early on, that was working on glucose responsive insulin. It's went out into a company called Smart Cells that was then bought by Merck, and Merck has been working on it. So once it went into Merck, it sort of went a little bit under the radar for us. We didn't have a lot of insight, but we do know that Merck is continuing to work on glucose responsive insulins. In the meantime, JDRF has been looking at what other types of innovations, along with the skin cat, are there other ways to get at glucose responsive insulin? And put out a prize challenge a few years ago to bring innovation into the place we've been working with. Big companies, some smaller companies, some innovative research groups to look at other approaches. The short answer is, Merck seems to have some things that we're getting in clinical testing. I don't know a lot about that flying under the radar, but there's lots of other companies and lots of other approaches to developing a kind of glucose responsive insulin. Again, something that I think makes absolute intuitive sense to everyone here. Wouldn't it be great if you could just have insulin turn on and off by itself, but huge challenges in terms of what kind of chemistry and engineering that takes to get there to have something that not only turns on quickly, but equally importantly, if not more importantly, turns off very quickly. So you don't have a lot of extra insulin floating around that gets turned on and then the blood sugar gets normal and keeps crashing. So challenges out there, but again, I think something where the kind of the role for JDRF as a risk taker getting involved and saying, yeah, there's lots of reasons why this is hard, there's lots of reasons not to do it, but hey, if this worked, this would be so fantastic that that's the reason why we're going to continue to try to drive innovation in that space.
So you were mentioning that one of the big problems is that even if you can replace the beta cells, they're still under autoimmune attack. is there any potential to take other cells and leverage their ability or like change their ability to secrete insulin and respond to glucose?
That's a fantastic question. So this is one of, so can you take a cell that doesn't want to make insulin, get it to start making insulin? And that is a really good question. So this is something I didn't really talk about, but it is, I think is incredibly appealing and incredibly attractive. And, you know, that's why I trained as a developmental technologist. And when I was doing my Ph.D. learning developmental technology, it's sort of cell-fate decisions are things that go down here, right? So the cell decides, you know, fertilized egg becomes 2 cells, the cells divide, they decide one's going to become skin, one's going to become muscle, and once they make that decision there. And then we now know that there's a huge amount more plasticity or ability to change among the cells in the body that can shift around. We know that if you push them hard enough, lots of other cells can make insulin and do other things. So you stick a bunch of genes that are already beta cells into liver cells or exocrine cells in the pancreas, you can get them to make insulin and push them there. One of the things I think is really exciting, we know that the alpha cells, they live right next door to the beta cells, and they normally make glucagon. And under some conditions, they can switch teams and start making insulin. So if you take a mouse and get rid of basically all of its beta cells and keep it alive with insulin therapy, some of those alpha cells switch teams and they'll start making insulin, and they'll eventually be able to get the animal to require it for exogenous insulin. So we've had a lot of work in that we call trans differentiation, so the switch in terms of changing teams there. It's still pretty early days in terms of understanding, you know, not just can it happen, but what are the triggers, what's the biology that drive that to happen, and then how do you turn that into a drug. But it is a very attractive approach, and I think as you sort of bring up, there's an open question, we still don't know the answer yet to. If you put back a beta cell in somebody with type 1 diabetes, the autoimmune disease is going to attack it, it's going to kill it. If you put back a beta cell that comes from a different cell, is it different enough that it won't look like a beta cell through the system? And we don't know the answer yet. I think that's something we probably won't know until we have something that we can give to people with type 1 diabetes to see, can we make the beta cells that will destroy the autoimmunity? But it's very intriguing possibility there. It's something that it was science fiction when I was getting trained. Now it's something that recognizing it not only as a possibility, but also looking at it as a potential therapeutic avenue.
I have one question. I used to work at a pharmaceutical company, so I'm kind of torn to ask this question. The question is, how is it that a drug that was supposed to be made for almost 100 years now costs $300?
Yeah. So this is, and I think this really points back to JDRF having a set-end rule. So it's around insulin pricing, and why is it that, you know, insulin prices seem to be getting out of control now, or more than seem to be. And you know, short answer is I don't know. I mean, there's lots of things that influence how companies price drugs. There's lots of things to consider. You know, when JDRF looks at what's the role that I think, so I'll answer it with one really practical part of it. What's really reasonable about that? So, and that really falls into our team in DC that looks at health policy and accessing it later. And they've been working really hard to try to understand from the insurance companies, how is insulin getting paid for? And really try to make sure that insulin is a low cost, it's a life-saving drug, and it's a predictable cost for people. I think it's also something that's it's very different in a room like this where, you know, most of the people here are well-educated, they have good access to healthcare, good health insurance. But it's also very different than folks that are on either no health insurance or high deductible health plans or not structured health plans. Where if you need to pay down your deductible first, you know, and the money isn't there for January to cover insulin costs, people that have money, that's not. So the DC team and the health policy teams work really hard on that. just to try to make sure that insulin is included in that preferred class plans whenever possible, that it's not subject to deductible or co-insurance or critical cost. The other side of it goes from now, insulins have been out there and available for a long time. When you look at the prices that have been going up tend to be for the newer generation insulins, and the whole NPH insulins haven't changed as much in terms of the pricing as other. So it also gets into this: how do you incentivize companies to come in and want to be able to develop newer and better instruments, but also make them affordable to everyone inside there? And it's a little bit of walking that balance between we want to get new things. We know that it's very expensive to make things and drugs in general, but we want to make sure that companies are incentivized to do that, especially moving into an environment where there's going to now be a role of biosimilar insulins and sort of like a generic form of insulin that puts new pricing pressures on the big insulin manufacturers. So it's a complex question that there's not an easy answer, and I think we need to look at it both from innovation on the cost side for companies as well as the payer and reimbursement side. We're really trying to get both of those. Yeah, I mean, it gets back to, at the end of the day, we can talk about all the new technology more into one of the first slides in there. Unless things are getting in the hands of people, things as basic as this one. We're not happy.
Because of time, I just want to thank you again very much for joining us. Appreciate it. A couple quick housekeeping things. I just want to emphasize, and I know Dr. Rakeman made it clear in his presentation, but it's because of all of you and all the people that you know who advocate for to raise money for JDRF that we're able to try to keep moving the ball forward on these many different fronts and trying to help all of our loved ones. A couple housekeeping things. We hope people will all join us on March 2nd, 2018 for 2019, sorry, for a Type 1 Nation, and then the upcoming JDRF Boston Gala, the annual gala in the spring, is scheduled for May 11th, 2019. So those are 2 dates that we hope you put on your calendars and consider joining us for both of them. And just as a final comment from me, and I know that Lisa and Sean will join me in this, the two prior chapter presidents. And this is a pretty exciting time in the world of JDRF and Type 1 research. And just in a short time, when my son has been diagnosed, we've gone from the Medtronic pump being a dream to actually being available and available to kids his age. So thank you all very much for your time this evening. I appreciate your attention on such a nasty evening, and hope to see you at another event soon.